World Regions Geography 110, South Asia, Part 1. Learning Outcomes. Describe the pattern of monsoon climate, its origins and key adaptations. Describe the physiographic regions, environmental hazards, and mineral resources. Provide examples of rulers, governments, and economic systems and history. Identify the major engines of recent economic expansion and uneven development. Describe the key relationships and borders that present the greatest geopolitical challenges, and summarize the region's greatest religions and explain how they have interacted globally, and explain the current and future demographic patterns and their major drivers. So here's the region that we're looking at, South Asia. We're talking about Afghanistan is included in that, Pakistan, India, Nepal, Bhutan, and Bangladesh. Now India exceeds over here and kind of wraps around Bangladesh. So it really takes in all this area here. Controls the major rivers in there, has the largest population, is home to the dominant religion, which is Hindu, but is also a very diverse country with some areas with substantial Muslim populations, Christian populations, and Sikh and Jainis down here. It's a very big region. Afghanistan, this region up here, is going to be critical to understanding current geopolitical situation. The reason this is so important is this is the pathway into Central Asia, right through here, through their region called Kashmir. And this is the single largest geopolitical problem facing India, Pakistan, Afghanistan right now. So the summer monsoon. So a monsoon means basically that there is a wet and a dry season. In India, the summer monsoon is the wet season. So during the summer, you get a dramatically southwesterly summer monsoon, which means the wind blows off of the southwest and up into this low pressure. If you take physical geography, you'll learn that low pressures pull winds in. So this is a high pressure down here. It's flowing towards the low pressure. So that's what's pulling it in. Now what breaks this off right here is this mountain range. That's the Himalayas right through here. This is a very high mountain range, and there's a concept called orographic effect, which means the moisture drops on the windward side, so on the side that's getting the wind. So in other words, most of the moisture is going to fall on this slope right here, and this area over here is going to remain relatively dry. Not a whole lot of moisture. Monsoon winds are warm and full of moisture. They're coming out of the tropics. You see right here, 10 degrees. It's almost at the equator. It is flowing out of the equator north into this during the summer, bringing lots of warmth and lots of moisture. Low pressure on the north side of the Himalayas draws the warm air north, and the Himalayas create an orographic effect, causing moisture to be deposited on this slope here. So you get a lot of rain, tremendous amount of rain over here during the summer. Winter, the dry season. Now in the winter you have the exact opposite effect. One, you have the high pressure sitting over the Tibetan Plateau right here, and that is forcing the wind is going to flow from high to low. So you have low pressure over here, sitting over here off the Indian Ocean, and it's going to pull this wind across in a northerly flow, flowing southerly. So what this wind is going to do is going to be dry because there's no moisture up here for it to pull. So it's going to a dry wind. It's going to be a dry, cooler wind, typically going to be very cold or very cool and very dry. That'll be the season where there's not much rain. Annual precipitation. And when you look at the annual precipitation, rainfall is concentrated June, July, and August. June, July, August. You see the monsoon kind of begins in May and can kind of extend over into October. But May and September, October are dramatically less. This is the height of the monsoon, where it'll rain virtually every day, rain a lot, rain hard. You can see you're getting about 60 inches of precipitation in July alone. I mean, think about this, is that California, if we get 15 to 20 inches in a year, 12 months, everybody's really happy. We get 20 inches, everybody's really happy. They're getting 60 inches in 1 month. I mean, even in these months here, they're getting more rain than we have in probably any month during the year. And certainly in September and October, they're exceeding California rainfall for a year. So, it's substantially wetter and for a very long period of time. Now you have lesser rain in May, September, and October, and it's virtually dry November through April. See, November, not much rain. I mean, it would be wet in California, 4 or 5 inches, but not really much for India compared to here. And December, January, February, and March, virtually no rain. It's much like our summer is here. South Asia climates. The area is susceptible to drought, particularly the northwest region, this region up here. Southern region is humid and tropical, so all of this region is humid and tropical. Northwest, dry and arid. This area up here, northwest, dry and arid, so it's desert. Not a lot of rain, dependent on moisture flowing out of the Himalayas. See these rivers right here? They're flowing out of the mountains there. The central mountain and plains are temperate. That's this region up here in the green. And the southeast region is susceptible to seasonal flooding. That's this region right here. This region right here in Bangladesh typically has a lot of flooding issue. It's very low lying. It is a river delta. It's the river delta here for the Indus River. And so this rivers typically flood every year. And the entire region is susceptible to climate change. This region here is particularly susceptible. All of the coastal region, which is fairly low, is susceptible to climate change. This region is susceptible because it would dry out, and with climate change, it may turn into a more desert, which even less moisture flowing in, because climate change could get rid of a lot of this moisture that's hitting up in this region here. One of the big dangers of climate change for a region like India, which is dependent upon the monsoon, is that if climate changes, it is the potential that the monsoon could decrease or go away. If that happens, this could become a large desert. Bangladesh is at sea level. You can kind of see this is the current sea level, and this is the low-lying area. You see the areas where people are over 1,250 people per square kilometer. That's a very small area. I mean, a kilometer's 1,000 yards roughly. So 1,000 by 1,000 yards. It's about 10 football fields by 10 football fields. and you got about 1,250 people living there. The majority of the country and the population live only a few feet above sea level. As you can see, this river here, this is a huge delta. This whole region here is a huge delta. And even moderate climate change would have dire consequences for this low-lying area. Now here are two projected sea level rises. One is 1 meter, which is about 39 inches or about a little over 3 feet. And the other is 1.5 meters, which would be about 5 feet. And you see how much of the country would be permanently flooded. Now the other part of that isn't shown on here is not only is this part flooded, but the storm surges and the seasonal flooding would extend way up here into this region, where now it typically is down in this region. So you would have much, much more. Now here is 1.5 meters, and this area extends it almost up to the very top of the delta here, and you would have flooding up into this region, the capital up there, Dhaka. So it would have severe consequences for the people living in Bangladesh. The Indian plate movement. So this is map to the right shows the trajectory of the migration of the Indian landmass into its current position. So about 71 million years ago, it started way out here in the middle of the Indian Ocean as just kind of a big island with a piece of that is currently Sri Lanka kind of tagging along. And then about 55 million years ago, it had moved up here, and about 38 million, 10 million years ago, it slammed into the Eurasian plate. Now it's continuing to move north, as you can see by this arrow right here. This was relatively all flat here, just like the area behind it. But this has been piled up, as you can see the mountains there. This is piled up, caused by this Indian landmass slamming into the Eurasian plate and creating what they call orogenesis, which is creating mountains. It's not only creating these mountains here, but it's also driving some of this mountain action here in Pakistan and in Iran. So, but you can see these are kind of connected there. And as this continues to move north, it's likely that the Himalayas will even get higher. So this collision is responsible for making this region a very active tectonic region. And that's this right here, tectonic risks. Very dark. Part of that is because of orogenesis and the creation of mountains, and it's this constant movement of this huge portion here into the Eurasian landmass, which is causing lift and shear. This area is currently an active orogenesis region. The Himalayas are the highest mountains on Earth and are growing. And you have a lot of serious earthquakes in here, and it's caused by these two plates grinding against each other. Major landforms. So you have the mountain rim region, tectonically active, experiencing orogenesis. That's this region all along here, along the Himalayas, the Hindu Kush, which are the passes, the Khyber Pass going into Afghanistan, and all the way down around here. You have peninsular highlands. That's the Deccan Plain in here. This is has a lot of very well jewels and gemstones from this region. It's very stable. It's an old landmass, volcanic in nature. And you have the coastal fringe, low-lying area. It's been weathered by the oceans. And then you have the plains region with desert plains and the grain growing region. That's this region through here. You have the rivers flowing there. Agriculturally, it's pretty rich. They grow a lot of wheat and grains in there.